Good morning everyone. So today we will discuss a very important chapter of class 12 that is integrals. Okay. In the previous chapter or in say class 11 you have already understood the concept about limits, derivatives. You have already understood the concept about differentiation, right? So today we will understand that what is integrals. So the first question comes, obviously we will do a lot of questions about integration, right? But what is integral? If someone asks us that whatever problem we are doing, but what is this integral? So integrals basically tells us a very simple thing. Integrals tells us that something is gathering how much or it is combining how much. Something is gathering how much. In Assamese if I tell kiba eta bostu kiman gut khai ase, how much it is gathering, how much it is combining, or you can say how much it is accumulating. That is only integral. Something is gathering how much. Okay, so let us take as a simple example. Say for example we are downloading a movie or say a game in our device, say in our mobile phone we are downloading a game. Okay, so basically what we are doing, we are basically accumulating data in our device. আমি আমার মোবাইলত কি কৰি আছো, data accumulate কৰি আছো, data gather হৈ আছে, right? We are downloading a game, but actually in our mobile data is accumulating. So say if you see this diagram over here, say in 1 second, say this much data is accumulating. Okay, in 1 second this much data is accumulating in our device. Say in 2 seconds this much data is accumulating in our device. Say in 3 seconds this much data is accumulating in our device. So now if I ask a question, tell me how much data will be accumulated, say for example in say 5 seconds, or say for example in 4 seconds. How much data will be accumulated in our device in 4 seconds? This is the main question. This is the main objective question of what? Integral. And the concept we will use to answer this question, that concept is known as what? Integrals. Now I'm sure you are thinking that this is a very simple question. Your answer is difficult. It's a very easy question. We can also even count and you can give the answer that how much data will be accumulated in 4 seconds or say in 5 seconds. So why is this integral so tough? Why the students are so scared about this chapter, that integrals? So later on we will come to know that there is a problem. Now this is a very simple problem, so that's why it looks easy, right? But there are some problem and that's why integral is so tough. Now this is very simple. How much data is accumulated in 1 minute or say in 1 second? Say this is minute, okay, this is minute. So how much data is accumulated in 1 minute? So you can also count 1 2 3 4 5, 1 2 3. So there are how much? 5 3 15, right? 15 data is accumulated. You can tell us 15 MB of data is accumulated. How much data is accumulated in 2 minutes? We can say same 15 15 30, 15 2s are 30, 30 MB of data is accumulated in 2 minutes. So similarly in 3 seconds 45. So if I ask the question how much data is accumulated in say 4 minutes or 4 seconds, whatever, so you can say 15 4s are 60 data. Now it can be 60 MB, it can be 60 GB, whatever it is. 60 MB, say for example 60 MB of data is accumulated in 4 seconds. And this is the main concept of integral. This data is an example, but whatever, how much something is accumulating, how much something is gathering, this is the main concept of integrals. So if I take this example, let us go a little bit more deep in the concept. And if we take this example in a graphical manner, if we try to understand this example in a graphical manner, so say this axis is time axis and this axis is our download speed, say for example. So then I can tell that this much, say this is say 4 seconds or 5 seconds, okay. So in 4 seconds or 5 seconds, say 4 seconds, this much of data is accumulated, right? From here if I start, this is 4 seconds, how much data is accumulated? This much data is accumulated, and this is only integral. Now I can also tell that this thing is nothing but, this shaded part is nothing but what? The area of this region. The area the region has enclosed is the shaded area. This shaded portion is the area enclosed by this region. So I can say that this data accumulation is nothing but the area enclosed under this figure. Let us once again recall from where we have started. We have started that what is integral, and we came to know that integral is nothing but something, how much something is accumulating or how much something is gathering, right? Kiman good khai ase bostu, how much something is accumulating. Then we came to know that this accumulation is nothing but the area enclosed under the figure. So you can check here, it is the area, right? 5 3s are 15, length into breadth, 5 3s are 15. Similarly, then 30, then 45, then 15 4s are 60. It is nothing, there will be 15, right? See, it is 45. Why it is 45? 1, 2, there is 5, 10, 15. 15 and there is 3. 15 3s are 45. We are doing the same thing. We are basically finding the area. So I can say that integral means how much something is accumulating, and how much something is accumulating. For example, here is data. Data is an example. And how much something is accumulating is nothing but what? Area enclosed. So from now on, if I say what is integral, from now on I will not say how much something is accumulating or gathering. I will tell in a more general manner that integral means area enclosed under that any the particular shape. Okay, integral means area enclosed. Okay, in more general way. In simple way it was how much something was gathering. Now I will not use that word. I will say that integral means area enclosed, because I have already seen that this is nothing but area. See, if we see say 2 or 3 more examples, say regarding physics, if you say this is time, this is speed. So again, here the area enclosed, here the shaded area, the area enclosed will give us what? Will give us distance. And we know that in lower class already we have studied the distance is equal to speed into time. Basically again we are finding the area only. Length into breadth, speed into time. Distance is equal to speed into time. So area under this region will give us distance. Understood? Even in class 11 I think so you have got that in a velocity time graph, if you find the area you will get the displacement. I think so you have got. Okay, velocity, if I write here velocity, will get what? You will get displacement. Similarly, say this is distance, this is force. If I find the shaded area, this area will give me what? Work. Work done is equal to force into distance, or you can say force into displacement. So understood? So area enclosed basically gives us what? The answer of integral. So integral means area enclosed. Now I know that this was easy. This was not so tough. Why is integral then so tough? The whole picture that we have seen, the whole story that we have seen till now, the story was very nice. The story was very easy to understand. But because still now in our story there was no villain. But now villain will come in our story. What is the villain then? Till now the story was very simple. Nothing difficult. It's length into breadth, force into displacement, speed into time. Yes, it is area. Yes, it is gathering. Yes, gathering means integral. So what is the difficult part then? So the villain has not came in the movie till now. Okay. So the villain is what? You see, why it was so easy? It was easy because we are finding area under what? We are finding area under straight lines. You see, all are straight lines. And that's why it was easy to understand. And why it is easy? Why finding area under straight lines is so easy? Because to find area in a straight lines, you see, there are two variables and one variable is always constant. Pay attention, okay? There are two variables and one variable is always constant. In this case, you see, time is changing 1 second, 2 second, 3 second, 4 second. But you see, our download speed is always constant. One variable is always constant. The download speed is always constant. But will it happen in real life that your download speed will always be constant? No, obviously no. You see over here what is constant? Speed is constant. Time is changing, but this variable, the speed, this variable is what? Constant. Over here force is constant, but this will not always happen in real life. And this is the villain. Because in real life we will not get always straight lines. We will get curved line. And this curved line is the villain. Okay, so let us see what is the difficulty to find the area in curved line. Okay, so let us see now. So let us see a more realistic scenario. Okay, because in reality always our speed or a force will not be what? Constant. So in reality what will happen? Say for example you went out of your home in a car. So this is time. So this is time and say this is speed, right? So our speed will not be same, right? Obviously, if we go out in a car, our speed will increase. It will decrease also. Say for now, let me just keep the diagram simple. Say this. Say this is the graph. Yes, obviously it will start from 0 only. Our speed will start from 0. Say I have drawn just from here, okay? So our graph will be something like this, and this is the villain, okay? This is the villain I am talking. So we have discussed a lot about speed, time, force, distance. We have talked a lot about some physics terms, right? So let us discuss in more general way. From now on, I am not going to talk about time. I am not going to talk about speed, force, distance. Let us discuss in a more general way, in more mathematics way. Say x and y. Okay, more general, not speed, time, not distance, force. Let us discuss in a general way. Say x and y. Okay, say for example, this same thing, if I discuss in more general way, say this is x, variable x, this is one variable, time, we will not discuss time now, say x, and say this is what, and this is say y, okay, and so this is the graph, okay, so it is increasing, right, it is increasing and slightly again you see decreasing here. So now this is very important. X and y must be related. There must be a relation between x and y. Say if you come here, there was a relation between time and speed. There was a relation between distance and force. That means you must know the relation between x and y. If you don't know the relation between x and y, then you cannot use the concept of derivative. You cannot use the concept of integral. Y must be a function of x. You must know if x changes, then how y will change. If x becomes 3, then what will be y? If x becomes 4, what will be y? So you must know the function. If you don't know the function, if you don't know, if time changes, you must know what will be the speed. If you don't know, if these two are not related, you cannot. So this is very very important, okay? This is very very important. Jodi ami function na jano, jodi ami na jano x change hole y keneke change hobo, you cannot use the concept of integral or derivative. Simple. So again the same question, that what is the area under the curve? This is the area, right? This is the area and we need to find the area. This is the area and we need to find the area under this curve. Now this is difficult. This is not so easy. Finding area under straight line is simple. You see in lower class also you have got a lot of shapes, like this shape you have got. Maybe in lower class 7 or 8. And how to find this area? These are all straight lines. You will divide it into trapezium, 2 trapezium and 1 rectangle, and you will add, you will get the area. You have got a lot more shapes like this, some kind of shape in lower class, right? We will divide it into rectangle, square, rectangle, and we will find the area. So finding area under straight lines was never a problem. Problem is to find the area under curves. You see there are 3 straight lines, 1, 2, 3. But the fourth one is curve, and this is the problem, or you can say this is the villain. Okay, this is the villain. This is why integral is difficult, because this is not so easy. For many years this curved line has created problem to mathematicians. Mathematicians got really troubled. They were troubled to find the area under curve. Digdar dise mathematician thik ase na, iman easy nohoy curved line area ulwa. So in the next part of the video, we will see that how mathematician finally got an idea. Mathematician bilake a trick pale, and using that technique, they found out the area under the curve. In the next part, we'll see. We'll discuss this integral, the concept part, and then we'll do the exercise part. We'll discuss this concept part in 3 parts. Okay. In the video, we'll make 3 videos regarding this part. First part, we have understood what is integral. Integral is basically how much something is gathering or accumulating. Then we came to know that that is nothing but the area enclosed. Then we have seen that yes, it is area enclosed, but it was easy. So what was the difficult part? The difficult part was curved line, because always in reality, in both the variable, one variable will always not be constant. It will change. It will change. It will increase. It will decrease. It will again be constant. It will increase. It will decrease, and that is the problem. And to find the area under such curved line is the challenge. And that part, how mathematicians solved, how they were finally able to solve this problem, how they have found out the area under curved line, we will see in the next part. Okay, so if you have any doubt regarding today's video regarding integral, any kind of question you can ask. Okay, in the next part we will see how to find the area under this curved region. Okay, thank you.